Hi everyone, thanks for joining our webinar today. My name is Joseph Jacks. People call me JJ. I'm here with my friend Johnny Karama, MSV, known as Johnny, and we're excited to share with you our presentation and demonstration on migrating Docker Swarm applications to Kubernetes. So in case you don't know who I am, I'll just give a quick introduction. I've been pretty heavily involved in the Kubernetes project, the community, since pretty much the beginning, to a little over 2.5 years ago. And I work at a company called Aprenda, where I joined recently. Johnny, do you want to do a quick introduction on yourself?
Sure. Hi, folks. This is Johnny Kiram. Short name is Johnny. I'm one of the Google developer experts from India, and I'm pretty excited to bring you this session on migrating Swarm applications to Kubernetes.
Awesome. So yeah, let's get started. This is going to be a really exciting webinar. So please feel free to ask any questions as we go through this, and we can wrap them up at the end. As we've gone through this webinar series, all of the attendees are actually provided $100 in Google Cloud Platform credits, which is really great. You can try out all the exciting new distributed systems, data, compute, networking services on the Google Cloud. We also offer annual monthly subscriptions to the mapped ebook library, and all of the recordings of the webinars are available and recorded for watching after and at your own leisure on Kube Live online, so kube.live. So getting into kind of providing a review on what we're going to cover. In this presentation, we're going to be going over what is available in Swarm mode, which is the new feature provided in the Docker engine for doing native clustering of Docker containers. We'll go into an example reference architecture of an application that will be existing running on Swarm, and then re-architecting and deploying that on Kubernetes and how all the transitions and migration components work. And then we'll actually scale and optimize that application in Kubernetes itself.
Cool. Thanks, JJ. So let's get started. Let me bring up a poll before we go any further. So I want to just make sure that you are familiar with the concept. So let me bring up a very quick poll, and then we can go ahead with the session and the demo. Excellent. So most of you are familiar with Docker, which is great because most of these demos are based on Docker, and subsequently we'll also move to the Swarm mode, which is available in the current versions of Docker. So let me bring up another quick poll just to understand how familiar you are with Docker Swarm and Swarm mode. So there are two different things. If you're familiar with the older Docker Swarm or the new Swarm mode based on SwarmKit, let us know. That would help me map the concepts better. Brilliant. So most of you are kind of beginners with Docker Swarm and Swarm mode. So this will also help you get a quick overview of Swarm mode, what it can do, what it cannot do, and how you can take those concepts to Kubernetes. We also have some interesting slides where we compare and contrast Docker Swarm with Kubernetes. So let's get started. Time for me to close the poll and take you back to the slides. Awesome. So what is Swarm mode? As you know, container orchestration is very important for managing containerized applications and microservices in production. So customers have a few choices. Of course, if you're familiar with Kubernetes, you know how to deploy, manage, and scale microservices through Kubernetes. The other alternative is coming from Docker Inc., which is called the Swarm mode. And of course, there are other options like HashiCorp's Nomad and Mesosphere's DCOS, but many are familiar with Docker Swarm and Kubernetes. So what is the difference between Docker Swarm and Swarm mode? So Docker Swarm existed as an independent orchestration engine for, again, managing the clusters and deploying microservices. Starting with Docker 1.0 1.12 onwards, Docker Inc. started bundling the orchestration engine, which is based on an open source toolkit called SwarmKit. And the SwarmKit is a part of the Docker engine, which means when you install Docker 1.12 or above, you essentially get the orchestration and the clustering capabilities right into the Docker runtime. So we are going to focus this session more on the SwarmKit rather than the older Docker Swarm, because Docker is trying to actually encourage customers or making them use more of Swarm mode. So the Swarm mode is initialized in one of the nodes, which will assume the role of a manager. And once you have a manager in place, you can add additional nodes, and these nodes plus the manager becomes a cluster, and you can start deploying and managing applications. One of the USPs of this is the simplicity, which means if you are familiar with Docker and use Docker CLI, you can pretty much continue to use the same tools, but manage the entire cluster and manage the entire distributed deployment. So that's a very quick overview of Swarm mode. There are some concepts that I want to touch upon, particularly if you are already familiar with Kubernetes, you will find this familiar. So there is a manager node, which is responsible for dispatching the submitted tasks to worker nodes. This is like the master, which is responsible for accepting the container definitions, which are actually called as tasks, and it would locate one of the worker nodes and would schedule the tasks on one of the available worker nodes depending on the requirements, the constraints, and the availability of resources. So the worker node is where the real action takes place. This is where the container gets provisioned, or rather gets scheduled, and the worker node receives and executes the task that is dispatched from the manager node. The manager node in itself can be a high availability cluster, which means you can deploy multiple manager nodes to bring in HA, and there could be multiple worker nodes. Docker recommends running 6 manager nodes for actually 3 for manager and at least 3 for worker. So that will make it a production grade deployment. And then there is a concept of service. A service is essentially a definition of tasks that are going to get executed on one of the worker nodes. So a service is slightly glorified version of a task. So basically what it means is, here is the task, which is the container, and then the service would define what are the published ports and how many copies of the task should be running. So think of the service as the container definition plus the published ports, the volumes, which is basically network and storage, plus how many copies, how many replicas of the task should be running at any given point. So that is the service. Task is basically the fundamental unit of deployment. One task is mapped to one container, and the commands are actually run inside the container. At some point, we are going to map these concepts to Kubernetes. You might actually find them already very similar and familiar. If you're able to map them, you're on the right track, because most of these clustering technologies are very similar and modeled around the same best practices of distributed computing. So moving forward, there is a load balancing as well. There is a load balancing concept where the manager node uses ingress load balancing to expose the services to the outside world, which means when you hit the manager node, because of the underlying network ingress, the request automatically gets forwarded to one of the available nodes. That again reminds me of a very similar concept in Kubernetes. But essentially, these are the high-level concepts of Swarm mode. Taking a closer look, there is an internal distributed state store that all the managers use to talk to each other, and that is the RAF consensus group, which will contain the single source of truth, and at any given point of time, any manager can query to get the state of the current cluster. So this is not shared with the workers. There is another layer of workers, and they use a gossip network to talk to each other. But the internal distributed data store is available only to managers to keep the state in sync and also to update them at every event. For example, when a new worker gets joined, the information gets updated in the internal data store. Every time a container is scheduled, the data store gets updated. Every time it is scaled, it gets updated. So basically, that contains the state of the current deployment, which includes all the master nodes, all the worker nodes, all the running containers, their replicas, the volume information, the network information, the ingress, everything is going to be maintained within that. And then this is how applications get deployed. You basically define a service which would contain the container name, which is the task, and the number of copies you need to run, along with the published port and the volume information. So this is one unit that contains a declarative description of what you want to do with your container. So you define the service and you submit that to the Swarm manager, and the Swarm manager would negotiate with the available nodes, and depending on your requirement and the affinity or anti-affinity rules, it goes ahead and schedules each of the tasks in the available nodes. It depends on how many tasks you want to run, what are the constraints that you put, what are the requirements you define, and any other information that you would provide as a part of the service would influence how each of these tasks get scheduled in the available nodes. So that is the very quick overview of Docker Swarm mode. Let's spend some time understanding the reference architecture that we are going to use for deploying an application in both the environments and comparing and contrasting them. So I'm going to use a very popular open source API management tool called Kong. And it's a true microservice in a sense that Kong in itself is stateless. It doesn't really store anything, and the persistence is moved to either PostgreSQL or Cassandra. That is going to manage the state. And you can scale out Kong depending on your scaling requirements. And since it doesn't contain any state, you can freely scale them across multiple nodes. There is a dashboard which is written in Node.js and Express framework, which talks to Kong and provides you GUI. And this is completely stateless. So you can deploy this application and scale Postgres for HA. You could run 2 PostgreSQL instances for high availability. You can run n number of Kong instances for scale. You can do the same thing with dashboard. And of course, each component is packaged as a Docker container. And we're going to deploy this application in both the environments. First with Docker Swarm. And when I say Docker Swarm, I actually mean Swarm Kit. So don't get confused. This presentation and this demo is targeting the latest version of Swarm, which is also called as Swarm Mode or Swarm Kit. So let's get started. I want to walk you through the complete experience of deploying the microservice in Swarm mode first, and we'll take a look at the concepts. We'll come back and map those concepts to Kubernetes and repeat the deployment in Kubernetes. All right, so let me start with the infrastructure. I have few nodes running or few VMs running in DigitalOcean. If you're able to see my screen, you would notice that I'm running a manager. There is worker 1 and worker 2. So this is my test bed for Swarm mode. And this is running the commercial engine of Docker along with the universal control plane, which gives you nice GUI capabilities to deal with the Swarm cluster. And this is actually packaged as Docker Data Center, which I have deployed on DigitalOcean. But the underlying clustering capabilities are pretty much coming from Docker's own Swarm mode. So that is the infrastructure piece of my deployment. So let me switch to the command line and show you what I have here. So currently I have configured my Docker client to point to the Swarm mode running inside DigitalOcean. So when I actually run Docker info, you would notice that this is showing me a lot of information. Let me make sure I'm currently pointed to the Swarm. No, I'm not actually running in Swarm mode. So I need to set some environment variables to make sure that I'm actually talking to the Swarm cluster and not to the local Docker engine. So for that, I need to basically run a simple shell script. So here I have already downloaded my client bundle. So I'm going to run this. And now when I actually type Docker version, this will show us two different pieces. One is the client, which is running on 1.12. You'd also notice that the server is running UCP 2.0. So UCP stands for Universal Control Plane, which is what we are running in DigitalOcean. And this is based on the Swarm mode capability of Docker. Now, at this point, if I actually run Docker info, we should be able to see the entire clustering information. So here you will notice that I have worker 1, its status is healthy, and then there is worker 2, which is also healthy, and all of them are managed by the master or the manager, and it shows us the number of containers and so on. So basically this is an indication that our Docker CLI, the client component of Docker, is now able to talk to the Swarm cluster. So now that we have this in place, let me first show you a deployment of our microservices application. For that, I'll take the help of a script here. So basically, I'm going to launch a simple container, which is running Postgres 9.4. And this is on my local host. I just want to run this application and show it to you. Then I'm going to launch my API gateway, which is actually Kong. And if you notice, this is linked to the Kong database that we just launched in the previous step. And finally, I would also run the dashboard. And all this is happening in my local machine. So now, when I actually do a Docker PS, you notice that I'm running 3 containers with the dashboard running on port 8080. So when I actually run localhost 8080, okay, I need to add HTTP. So this opens up a browser window and then takes us to the dashboard. And this is configured to localhost 801, which means I can now go ahead and create APIs. So I can add an API and make this a proxy for my existing API endpoints. That's beyond the scope of this demo, but you get an idea on what we're going to do with this deployment. So basically, this is an API management microservice that we are now going to run in a cluster of Swarm. So let's leave this as it is, come back to the environment that we configured to talk to Swarm. So now I need to go ahead and launch my cluster. So I need to run a few commands. The very first thing that I need to do is to create what is called as an overlay network. So this overlay network would ensure that all my services use a specific network backbone that they can talk to. So now we have gone ahead and created a network. So let's test this. So you'll actually see that there is a new network that is created called CongNet in Swarm mode. So this is going to be the network that all our microservices will run on. So that's the very first step. The next step is to launch the stateful database. And this is where we are going to use a new addition to Docker called service. So Docker service is a new command. You can actually do Docker service ls. And it is currently running only the UCP agent, the Universal Control Plane agent, and there are no applications currently running. So Docker service is used to submit a task to the manager. So it borrows a lot of parameters and switches from the standard Docker CLI. So I give the name of the container, then I publish the port 5432, and we are creating a replica of one. It's a stateful service, and I'm not configuring this in HA, so I'm just launching one. And this is an interesting switch that tells that we are going to launch, we are going to create a volume called db underscore data, and this is mapped to the internal container directory, which is varlib PostgreSQL. Essentially, this is where we want to mount all the data files and log files. This is equivalent to creating a Docker volume, but this command, this switch, would essentially add at the swarm level. Then I mentioned the network that I want to launch this container on, which is called congnet that we created in the previous step. I pass some environment variables, and finally we give the image name. So let's go ahead and run this command, which would create the Docker Swarm service for Postgres. And at this point, we can come back and check the status by typing Docker service ls, and this shows us the database being created. So 0 of 1. So let's leave this as is, come back, and now I'm going to launch the stateless API server, which is Kong itself. And I'm basically binding this with the previous database container by passing a couple of environment variables. So Kong database and Kong PG host will indirectly bind my stateless service with the stateful service. So let's also run this. And when we check the service status, you would actually notice that Postgres is up and running and Kong is now getting created. So the next step is to launch our dashboard. So I'm going to run the final command, which is again stateless. So I'm not using any volume to mount, and I'm just using one replica. We are launching this on congnet so that it can discover the other services that are exposed on the same network, and we are publishing port 8080. So now we should have 4 services, including the system service, which is UCP, and they are just getting launched. So at this point, I want to take you to the Docker UCP interface, and this is the GUI experience of dealing with Swarm. So when you go to the dashboard, you actually notice that there are resources, there are services, and there are containers. So let's go to nodes. So this is a list of all the nodes that we are running. So there is one manager, which is nominated as the leader. There are a couple of workers, and all of them are running the Swarm infrastructure. And then we go to networks, and you notice that there is congnet, which we created from the CLI. You can also create it interactively with the button here. Then you can go to volumes, and here you notice that we have created the db underscore data volume. There are other instances which are basically from my previous dry run, but only one is relevant for this scenario. And then when we go to services, we should see exactly 3 services, and all of them are green. So there is a Kong database running PostgreSQL, there is Kong, and then there is a dashboard. And when you click on any of these services, you'll notice that they publish these ports. So this is an indication that our service is now up and running. So now I'm going to go to the dashboard and launch the dashboard. So when I click on this link, it basically takes me to the browser window, and it is already configured because it picks up from the local host. It basically replaces the same IP address and points to 8001 port. So now the Kong dashboard is up and running, which means our microservice is completely in running mode. You can go ahead and now register your APIs and use this as a mature proxy for all your APIs. That's not all. Once you have the service running, you could come back to the command line and use the Docker service scale command to run multiple instances. So what we can actually do now is we can scale Kong to 5 instances. So now the stateless Kong service is scaled to 5 replicas. And we can do the same thing for the dashboard. We'll actually run 10 instances of the dashboard. So now this gets scaled to 10. And what it really means is when you actually look at the status here, you will see the desired count and the current count. So they get updated in a few seconds. So currently it is launching all the new containers, all the new tasks that we submitted to the manager. You can come back and take a look at the container section, and this shows that we have effectively scaled the dashboard, the UI part of it, and the actual API gateway. In a few seconds, everything will turn green. If you really want to expose all of them and load balance, you could use either an inbuilt load balancer that comes with SwarmKit, or actually Docker Data Center, which is called the interlock, or you could also take the port on which we are exposing and set up a load balancer like Nginx just ahead of your UI port. So you basically hit the load balancer and the traffic gets routed to one of the worker nodes, and from one of the worker nodes it will actually hit one of the containers that is running the UI component of it. So that is essentially how you deploy services and scale them. So this is a very intuitive, simple way of using Swarm. So let's now come back and take a look at, for example, Docker volume ls will show us all the volumes that are currently running, and we should see these are all system volumes, but there is one db underscore data that we created. Cleaning up is pretty straightforward. I can use Docker Swarm RM followed by the service name. So this is how you get rid of an existing service. So pretty much we covered the entire cycle of defining a service which contains the task, and we have gone live and we tested the end-to-end application. That is perfect. So now let me take you back to the slide and do a quick recap of Kubernetes architecture. So now it's time for us to map some of these concepts to Kubernetes and repeat the same deployment, and we'll find the subtle differences that we have when we actually deploy this app in Kubernetes. So for those who attend our webinars regularly, you would find this slide familiar. We covered this in Kubernetes architecture and Kubernetes 101 in the very beginning. So essentially you have a deployment which contains the pod plus the replica set definition. You submit that definition to the master, and the master would again pick up a node based on the scheduling strategy and deploys the number of pods in one of the available nodes. The top gray bar that you see is essentially the Docker registry, which could be public or a private registry, and the container images get downloaded from the registry to one of the nodes. The node itself would run a few components, like, of course, the Docker runtime, followed by a kubelet, which is actually the agent that talks to the master. There is a kube proxy, which manages the network. There is fluentd for log management, and supervisord, which is the surrogate process manager for Docker and the kubelet. So this is a very quick overview and a recap of Kubernetes architecture. Now let's map some of these concepts that we have seen with Swarm to Kubernetes. So Swarm calls its leader as the manager node, and in Kubernetes we call that as the master. Essentially both of them are responsible for exposing the API and talking to the clients, and the jobs, tasks, or whatever you call as the unit of execution is submitted to the master or the manager. The workhorse is called the node in Kubernetes. It's called the worker node in Swarm. Both of them are responsible for scheduling a container and managing the life cycle of one container at a time. And it negotiates with the underlying Docker engine or any other supported container runtime in case of Kubernetes. Service is a very interesting concept, which is basically nothing but a deployment in the Kubernetes world, because a service contains the container definition plus the number of replicas that you would run at any given point of time. So that sounds a lot like a pod plus the replica set. And that is what is called service in Swarm. And this is actually called as a deployment in Kubernetes. When you define the combination of a pod plus the replica set with the mount points, and you, of course, service also contains the networking information, which means it's a combination of pod plus replica set plus a service. So when you bring all of them together, it is a service. There is a reason why Kubernetes maintains them separately. It's a clear separation of concerns. The developers need not really deal with the proxies and the networking or the storage elements. It is a job of the ops, and that there is a clear separation of concerns there. Okay, now coming back to the mapping, the task is nothing but a pod, which is one container per definition. That sounds a lot like a pod. Of course, pod can contain multiple containers, but essentially a task maps to a pod. Replicas are a straight mapping or straight equivalent of a replica set. Both of them will scale out or scale in the containers at runtime. In terms of discovery, this is actually, I have a better slide, I guess. Yeah, this is a better slide. So let me use this. So for service discovery, both use DNS, but there is a subtle difference in the way DNS is being used in Kubernetes. This is actually, there's a better way of doing networking in Kubernetes based on flat networking, which you will realize when you port applications to Kubernetes from any other environment. It is far more easier for you to deal with the service discovery. It's almost a no-brainer as long as you maintain the right naming convention for your service endpoints, for your services. The discovery happens pretty seamlessly. In terms of load balancing, again, it's very transparent in case of Kubernetes. It happens through a proxy, which is exposed through a service. So it doesn't matter where the container is scheduled. It could run in any of the nodes. You can hit any node, any port, and it gets bounced to the appropriate endpoint. The port is exposed as published port in Swarm, and it's called the endpoint in the Kubernetes world. But essentially, both of them expose a port to the outside world or within the cluster. Storage is far more mature and aligned with ops. So ops can basically define persistent volume claims, and they can define quotas, which will translate to persistent volumes that the containers and the pods can take or make use of or consume. There is no such concept in Swarm. You basically create a volume before you deploy a container or along with the container, and it becomes available to your runtime container environment. Networking, as I mentioned earlier, you have to be more explicit with Swarm, and you have to deal with quite a few intricacies like creating an overlay network, then dealing with ingress, then dealing with interlock, and then creating an external load balancer. So you got to be very, very familiar with networking concepts like layer 7 load balancing, layer 4 load balancing, and you got to know quite a few nuts and bolts of networking to actually expose services internally and externally. Whereas when it comes to Kubernetes, the networking is flat. Thanks to a component called kubeproxy and IP tables, there is a very transparent implementation of networking that you never need to fiddle with. You basically define your endpoints, you define a service, you deploy it, and everything happens auto-magically within the Kubernetes cluster. So it's a very clean implementation. So we have seen these components, and now let's actually take the same application and deploy it in Kubernetes running on Google Container Engine. And I want to highlight some capabilities and some optimization techniques that you can take advantage of. So let me take you back to my browser. And here I want to show you my favorite environment. So I'm currently running a 4-node cluster in GKE, Google Container Engine. And if you are not familiar with Google Container Engine, this is a managed Kubernetes based on compute engine. So every node that you launch in the cluster essentially translates to one VM running in GCE. So we are running 4 VMs that are mapped to each of our nodes in the Kubernetes cluster. It comes with many advantages like auto upgrade and complete SLA. So you never have to deal with the underlying infrastructure. You only submit your pod definitions and deal with the lifecycle than dealing with the infrastructure. So we have the Kubernetes cluster running here. And I have already configuring the client is also pretty straightforward. You just need to run this command, which will point kubectl to the cluster running in GKE. So let me take you back to the command line, and here we are. So kubectl get nodes will confirm if we are talking to GKE, and there we see 4 different nodes which are essentially talking to the GKE endpoint. And then let's see if we are running any pods. There are no pods at this point. So it's pretty straightforward. We're going to deploy a 3-container microservice, and then we'll actually access that. And in that process, we will understand the differences and also learn more about Kubernetes concepts. All right. So I will again take the help of my script here. So I'm going to first launch all my containers in one go. So this single command basically launches our application. Let me hit this, and while it is getting deployed, I'll walk you through what I'm actually doing here. So first thing is our database deployment. So if you actually see, we are launching the replication controller, and this is running Postgres. So there are a lot of similarities between what we have seen earlier. For example, here you would notice that we are calling this as Kong database. We are creating a mount point in Swarm, and we are passing a couple of environment variables. The same thing happens here. We are launching a container from the Postgres 9.4 image. We are passing a bunch of environment variables, and we also expose port 5432 to the internal cluster because we never want to expose this to the outside world. We created a host-specific mount point, which is called PG data, and we are mounting the varlib PostgreSQL data to PG data. So this will ensure that even if the container is crashing or if it is dead, when it comes back, it picks up from the state that was persisted to the underlying volume. So this is the definition of our database. And then we expose this as a cluster IP. If I don't specify what kind of a service endpoint that I'm exposing, it defaults to cluster IP. And this is pretty straightforward. We are launching a service where we are exposing 5432 to the internal cluster, and this is based on TCP. And the selector is Postgres, which is what we define here as the metadata. Name is Postgres, and label app is Postgres. And this is what we are using to associate the service with the underlying database container. So that's about the data tier. With that in place, let's take a look at the app. Now, app actually uses a deployment. This is a new terminology that we haven't covered in the webinar series, but deployment, as I mentioned earlier, is a combination of a pod plus replica set. So the advantage is you can actually perform rolling updates, and you can reconfigure with very minimal or sometimes even no downtime. So this is our Kong replica set, and what we're actually doing here is launch this image called mashape Kong, and we are feeding the environment variables that will associate our container, the Kong container, with the Postgres backend, and we are exposing a bunch of ports all the way from 8000 to 8001 and a set of ports. This will get launched, and we are defining one replica at this point, and it automatically discovers our database because we are actually using the same name as we defined for the port. So Postgres is going to be the service endpoint. So Postgres, now this is what we will end up discovering at runtime. So this is again very similar to what we have created here. One replica, couple of environment variables for discovery, a bunch of ports, and since it is stateless, no volumes associated with it. And then of course we expose this with two services. One is actually for administration. So there is port 8000, which is meant for proxy, and port 8001, which is meant for administration. So we go ahead and launch this, create this service, and we'll expose two endpoints out of this. And finally, we have dashboard. Dashboard is pretty straightforward. So if you look at this definition, it's again a deployment, and it contains the pod definition as a part of the replica set, and we are exposing 8080. The only endpoint that will be exposed to the outside world at any point is this. So that is what we're going to expose in this service. And if you carefully notice, we are using type load balancer as the ingress. So which means this service is going to be bound to a GCE load balancer, and I can map it to a C name or an A record depending on my configuration. And every time I hit that, it automatically routes it to the endpoint exposed by our dashboard. One thing that you would notice is we have broken the deployment into multiple definitions, but understand there is a reason for doing that. This is making it extremely clean and also bringing in a level of modularity and separation of concerns. So ops folks who are very familiar with networking can deal with services alone. Again, storage folks will define storage independent of the deployment. And then there is a Kubernetes operations team that creates the replica sets and deployments, and they are responsible for bringing everything together. And developers only focus on a pipeline that will build their source code into an image, and that gets pushed into a registry. So there is a very clean separation of concerns and responsibilities, and every role in your organization can stay focused on one task at a time. And since we are basically breaking it down into different layers, it's easy to manage and update. For example, after I have gone live with a service and I want to update certain ports or change the endpoint, I need not touch existing containers. Thanks to the concept of labels and selectors and annotations, I can basically launch a new service with the same set of selector and gracefully bring down this service so the new endpoint becomes effective. And even before anyone realizes, I wire it up to my C name or A record, and the traffic starts flowing again. So there is a reason why Kubernetes clearly separates these entities, these API objects, and it brings in tremendous level of separation and isolation, which is required for managing production workloads. All right, so let's go back to the command line and take a look at where we are. So let's make sure we have all the pods running. So now we have all the pods in running mode. We also have a bunch of services running. So the admin is exposed at the cluster or at the node port level. Proxy is also exposed at the node port because we want to access it from the outside world. Kong UI is actually bound to a load balancer, and this IP address is coming straight from the load balancer. We will take a look at it in a second. Postgres is again at a cluster level. It doesn't have any outside port. It is again a cluster IP. So the only way to talk to the service or the entire deployment is through this ingress endpoint, which is mapped to a GCE load balancer. So pretty straightforward. So now let's go ahead and discover the service. So let's discover the Kong UI service. Oops, describe service Kong UI. So this shows us that the type is load balancer, and load balancer ingress endpoint is coming from this. So this is a very powerful concept. We never used the command line or anything to actually access this. All right. So now let's hit the endpoint and register our API endpoint and quickly access this. So all I'm going to do is grab this and again just open the URL. And there we go. So now it is asking me for the URL, and this URL is coming from the node port, which is the admin URI. So how do I access that? It's pretty straightforward. I need to get the public IP address of one of my GCE instances. So I'm running a nifty command here, which will only publish the public IP addresses of my GCE instances. So I'll grab one of the IP addresses. I can actually grab any IP address from the node because thanks to kubeproxy and the flat networking space, when I actually hit the appropriate endpoint on any of the port, which we are going to discover now. So kubectl describe service Kong admin. So this will show us that for the outside world, the Kong admin service is mapped to a node port of 30395. All I got to do is feed that to my tool, and there we go. So now we have a fully configured deployment running on Kubernetes. And after this, guess what? It's pretty straightforward to scale. So kubectl scale replica Kong UI is equal to 10. So this is going to now, oops. Oh, okay, I think I missed the syntax. Okay, this is the problem when you are using too many tools at the same time. So kubectl scale okay, am I missing the okay, never mind. I am very familiar with Kubernetes. So now I'm going to come back to the dashboard, which I wanted to show you anyways. And I want to show you the replica sets for the Kong dashboard. We'll come here and then we'll edit this definition. Okay. And what we'll actually do is update the replicas from 1 to 10. Okay, so now we have successfully scaled the dashboard replica set from 1 to 10. This is a very powerful UI. JJ's team initially contributed to it, which has matured over a period of time, and it has saved my day today. I actually missed that command, having spent last 48 hours with SwarmKit and Swarm. I missed out on the syntax and the semantics of kubectl, which is funny, but thankfully you get an idea. So this is by the way is called the Kube UI, which is very similar to this. This is basically the Docker data center UI, and this is Kubernetes UI. So you look at the nodes. You also get very nice graphs of this resource utilization. You take a look at the deployments. You take a look at the replica sets. You take a look at the pods, it's a pretty clean way of accessing the deployment through a beautiful user experience. All right, so one final time, kubectl get pods. They should, okay, it hasn't really launched multiple dashboards. Never mind. What I'll do is I will come to the deployment, which is going to be the dashboard, and I will update this to 10. And what I'm going to use is kubectl apply followed by our dashboard.yaml. So this will now reconfigure the dashboard RC. So now when we actually do kubectl get pods, so we should see 10 of them getting launched. This is exactly what I wanted to see. So there are multiple ways of applying the same change. Somehow the UI didn't get effective, so I switched to my YAML definition, updated, and reapplied that. This is how you basically do configuration updates with very minimal downtime. All right, so that brings us almost to the end of our presentation. So let me take you back to the slides. Wow, my screen just froze. Okay. Okay, sorry about this. I'm just trying to recover my slides back and I just can't find them. Never mind, I will open them again. So these things will actually prove that we are doing live demos and these are not like recording or or some kind of canned demos. So you actually get an idea of what we are going through. So brilliant. So that brings us to the end of this presentation, where we walked you through the concepts of Swarm and deployed an app, walked you through the life cycle of managing a Swarm application. Then we covered how to map those skills to Kubernetes, and we repeated the same process with Kubernetes. And in that entire life cycle, we learned how to create an ingress endpoint with GKE based load balancer, GCE based load balancer, and what are the subtle differences between the Kubernetes architecture and Swarm. They're not actually subtle. Some of them are, they seem to be subtle, but they're extremely powerful. So this brings us to the end of this webinar. So it's time for me to pull up the last poll where we collect your feedback. So really appreciate if you can take a minute and respond to the poll. It helps us fine-tune the content to your needs and also encourages us to do better with the content and delivery. So appreciate if you can take a minute and respond to the poll. All right. So now time for me to look at some of the questions. Okay, I'm seeing a lot of responses on how to scale from kubectl. Thanks for that, but I could show you the other way of doing it. Okay, many of you are saying you haven't received the credits, but if you are registered and if you participated in the webinar, you would very much get the credits because it's a process that I follow. Typically over the weekend, you would receive an email with the links to the slide, the YouTube video, and if there is a source code, the GitHub repo link, and all the assets that belong to this session. So in case you haven't received, let me know. I'll be happy to share them again, or you could go to YouTube and take a look at all the existing videos. Are you going to compare Mesos with Kubernetes? Absolutely. Stay tuned. That's in the pipeline. We have many exciting sessions lined up for 2017. Any tools recommended to help migrate Swarm to Kubernetes? Interesting, but before someone really invests in a tool, Docker should stabilize and Docker should decide what they want to do with orchestration. So currently there are 3 different ways of orchestrating Docker containers coming from Docker Inc. The first one is the good old Docker Swarm. Then the second one is using Docker Data Center powered by Swarm More or the Swarm Kit. The third one is Docker Cloud, which is their acquisition of Tutum. So Swarm has different meanings, and it's very confusing on what to use, what not to use, and the syntax, the semantics, and the nomenclature is extremely different. Like you can't take a Docker Compose file and run it on SwarmKit, and the same Docker Compose file would work with the older Docker Swarm version, and the same thing wouldn't work on Docker Cloud. So there are too many permutations, too many combinations. Before someone creates a tool for automatic migration, I think it makes sense for us to wait on what Docker wants to do with their orchestration tool. All right. Cool. Looks like there are not many technical questions. So thanks again. JJ, you're still there, right?
Yeah, I'm here. Yeah, that was really great, Johnny, and I couldn't agree more. The concepts and the options with the native Docker tooling are definitely shifting and moving around and confusing. So waiting for some stability there before recommending a path from Docker Swarm to Kubernetes makes a lot of sense. However, there is a tool called Compose with a K that provides some translation and parsing of Docker Compose manifests to Kubernetes manifests and configurations. But again, it's not a complete answer to the question.
Yeah, JJ, it's interesting that you brought up Compose. I actually tried using that for the demo, but unfortunately, as I mentioned, the Compose definition wouldn't work with the latest version of SwarmKit and the data center. So that tool just works with the legacy version or the most stable version of Docker Swarm, which was available pre-SwarmKit days.
Right.
Cool. So we are not announcing the next session at this point because we want to get past the holidays, figure out the next cycle of webinars, and we will come back to you on the next schedule, the topics. Stay tuned, and thanks for attending these webinars. So have a great holiday season, and look forward to having you in the new year for the Kubernetes Live webinar series. Thanks once again, and JJ, thanks for joining and supporting me.
Thanks, Johnny. Thanks, everyone.
Cool.